All right. We have done some stuff with motion before. We reviewed it not terribly long ago. And I wanted to do an entire motion unit. And so that's what we're going to start today. And today is mostly review stuff for you. So we're not, the notes today are really pretty short, just to remind you of some things. So,
Is this like physics, basically?
um, kind of, but not exactly the same thing. Um, so there are three related concepts that you have to keep straight. These are position. And if we're moving along the x-axis, this would be x of t. And then there's velocity. We usually will use v of t. This is the rate of change in what? Position. So it is x prime of t. And then acceleration typically we'll use a of t for that, which is the rate of change of what?
Velocity.
Of velocity. V prime of t or x double prime of t, same thing.
So cool.
So some other things that you'll see in problems. If the problem says initially, what does that tell you is equal to 0?
All x of t.
No.
It means v of t.
Nope.
I mean, nothing could be equal to 0.
No, when you say initially, there's something that's equal to 0.
Fine.
Yes. T is equal to 0. If they say that you're at the origin, what does that mean?
X of t.
Yeah, x of t is equal to 0. At rest means v of t is equal to 0. If we're moving along the x-axis and the velocity of the particle is positive, then the particle is moving which way? To the right. Occasionally they'll have it moving along the x-axis. Excuse me, the y-axis, in which case it would be moving up. If the velocity of the particle is then the particle is moving to the left. Negative. To find the average velocity over a time interval, divide the change in what by the change in time?
X of t.
Yeah, x of t, position. Change in position over change in time gives you the average velocity. Instantaneous velocity is the velocity at a single moment in time. So that is just your x of t. If the acceleration of the particle is positive, then what's increasing?
The velocity.
The velocity is increasing. And if the acceleration of the particle is negative, then the velocity is decreasing. Okay, this is an interesting one. In order for a particle to change direction, remember it's moving along a line. So if it's going to change direction, what has to change sign?
Velocity.
The velocity has to change sign.
Couldn't the acceleration also have to change sign?
If it changes sign, you can still be moving on.
You can have the velocity change sign without the acceleration changing sign.
Yeah.
So,
But wouldn't changing the sign of acceleration eventually change the sign of the velocity?
Yeah.
if the sign of the acceleration changes sign, then eventually, at some point, the velocity is going to have to change sign as well.
Unless you have positive acceleration with a very negative velocity, you move a little bit and then you change.
And then
the
you change it.
acceleration, goes back.
Yeah, so, yeah,
Not really worth making the claim.
no. So one way to determine the total distance traveled over a time interval is to find the sum of the absolute values of the differences in position between all resting points. We haven't talked about this, but let's take a look and see what happens. So we're trying to find the total distance traveled over a time interval, and we're given x of t is this. So we want to find out where are the resting points. How do we find the resting points?
You have to take the derivative to get the velocity.
Right? So v of t is going to be equal to t squared minus 2t minus 3, and that's got to be equal to 0 to be at a resting point. So then, factoring that, that's t minus 3 times t plus 1 is equal to 0. So t is equal to 3, or t is equal to negative 1. We'll throw out the negative 1 because we're on an interval from 0 to 6. So one way that we could do this is we could take the absolute value of the differences in position between resting points. So what we would do is take the absolute value of v of 3, x of 3, the position, minus x at 0, plus the absolute value of x of 6 minus x of 3.
So this could be a problem where, like, if a particle was moving positive and then moved back to the negative,
Correct.
but you want the total distance.
Correct.
Just use an integral for this.
Yes. So this is one where the lady that let me use this, Dixie Ross from Pflugerville.
High school.
Although I don't know if she's at Pflugerville anymore. I think she moved to another one in the Austin area someplace. So you could do the integral from 0 to 6 of the absolute value of v of t dt. It's the same thing. What she was doing on this is she was doing this before they had learned antiderivatives at all. And
So they couldn't do it by
Already
hand.
have the antiderivative.
pardon?
Already have the antiderivative.
But he's saying that she would teach her students this before they learned how to do it.
I know that.
Yeah. So what she did actually, she did this and then did other things, and then she did another part on motion and did other things, and then did another part on motion. So yeah, you could absolutely do this. When you do this, you have to break it into pieces where the velocity is positive and where the velocity is negative. Where is it going to change? when it's at rest, or at least it has the potential to change there. Let's go ahead and finish this, and then let's compare it to this. Okay, so here, x of 3, let's see, that'll be 9 minus 9 is 0, minus 9 is negative 9, plus 4 is negative 5. And x of 0 is 4, plus I know x of 3 is negative 5. X of 6, see, that's a third of 216, so that's 72 minus 36 minus 18 plus 4. So it's 36, 18 plus 4 is 22. Yeah, you guys are far too trusting.
I mean,
Well,
you're my math
simple
teacher.
math. I
I hope.
you were calculating the amount of,
Swallow.
anesthesia you were going to give me. I'd have a little more concern.
I would be concerned that he's practice. He doesn't have any credentials.
Yeah, you would have other concerns. So it appears to be 36.
I'd rather
So if we did this by integrals, one of the nice things about this is we didn't have to worry about, well, when is the velocity 0 and when is the velocity positive? Or when the velocity is negative. We do have to worry about the velocity being 0, but we didn't have to go, well, on this interval it's this. So if you do it by integral, yes?
Well, I'm going to take a gander at something. Since I
No,
know.
a gander is a look.
Okay, no.
We've had this discussion before.
Let me have. All right, I'll take a shot at this. Since our big power in x of t is 1/3 x cubed, right? That means that's the overall end behavior of the graph.
Yeah, but we don't care about the end behavior. We're interested on the interval from 0 to 6.
I think from 0 to 3, v of t is negative.
Well, you had a 50-50 shot of getting that one right.
And from 3 to 6, it would be positive.
So let's look at the velocity from 0 to 6. We know that at 3, the velocity is 0, right? So let's real quickly substitute in some value between 0 and 3, and it's always easier to substitute it into the factored form, because you only care if you have something that's positive or negative. So if I choose 1, negative times a positive, the velocity is indeed negative. And from 3 to 6, if I pick 4, I have a positive velocity. Positive times a positive is positive, the velocity is positive. So here I would have to divide this into two separate integrals. The integral from 0 to 3 of v of t dt. And you have to take the opposite of that because the velocity is negative, plus the integral from 3 to 6 of v of t dt. So let's see. The integral of v of t is going to be x of t. Oh, well, that's nice. So I'm going to have the opposite of 1/3 t cubed minus t squared minus 3t plus 4 from 0 to 3 plus 1/3 t cubed minus t squared minus 3t plus 4 from 3 to 6. And isn't that exactly what we did here?
Yeah.
So you're exactly correct.
Well,
thing you didn't take a gander at it.
I mean, I can't watch. I'm not looking. Take a look. Not looking. Not looking. Take a look. Not looking.
All right, that's it for the lesson. You have your homework.
And